Here we'll examine measures of dispersion in data sets. One of the simplest measures of dispersion is the range of a data set. That's the overall spread of the data, and we find it by subtracting the highest entry minus the lowest entry. This data set here is put into order, which is great for finding the range, because we can easily identify the lowest data piece and the highest. Now all we have to do is subtract them. The range is 19 minus 0, which is 19. Now let's calculate what might be referred to as deviations or residuals for each data piece in a data set. This is going to be the difference between the entry and the mean of the data set. So the first thing we should do is calculate the mean. That's the average. There are 5 4s, so it's actually pretty easy to figure out what the mean of this data set is. The data is all made up of 4s, so not surprisingly, the average is 4 as well. Now let's find the residuals. To show it, I'm going to make a graph. And the graph can be numbered from 0 through, let's say, 5 or 6. On the horizontal axis, I'm simply going to label the different data pieces that were taken. There are 5 of them, so I'll label them with the letters A through E. It's also going to be important for this diagram that I draw the mean as a dashed line at 4. That's the X bar. Now I want the height of the dots that I'm about to draw to equal the values of the data pieces. So A was a 4. This guy can be A. And this is B. This can be C, D, and E. B is also a 4. C is a 4. D is 4. And E is 4 too. So what we notice here is that every piece of data exactly matches the mean. And now we're going to calculate the residuals. To get the residuals, we'll make a table of X, X bar, and then we need to subtract X minus X bar. X stands for the different data pieces. Let's list them all. There was 4, 4, 4, 4, and 4. 5 4s. We also calculated the mean. The mean is also 4. I'll put the mean next to each data piece. Now we subtract X minus X bar. So it's the first column minus the second column. 4 minus 4 makes 0. 4 minus 4 makes 0. 4 minus 4 makes 0. They're all going to be zeros. The reason why is there is no deviation from the mean in this data set. I bring up that simple example because now we'll try it for a data set that does have variation in it. Let's label our samples again. A, B, C, D, and E. We'll calculate the mean of this set. Once again, we get 20 over 5, which is 4. So interestingly, both of these data sets have the same mean, but they are not the same. One of them is a little bit more spread out than the other. Here I'll draw the same type of diagram that I had drawn above. 5 samples, A, B, C, D, and E. Let's label our axis here. The mean was 4, same as above. Now we let the heights of the dots that we're about to draw equal the value of the samples here. So A has a value of 2, so I have to go up to here. B has a value of 3. C had a value of 4. D has a value of 5. And E's value is 6. We see quite a different graph. And the residuals are the differences between the samples and the mean. As you can see, each sample here has a different residual. Now let's go to a table where we can actually calculate the size of the residuals, and also we can give signs to them, as in positive or negative. Our data was 2, 3, 4, 5, and 6. The mean is 4, and that's the same for the entire data set, so all we do is just repeat it throughout the table. Now we subtract. 2 minus 4. It makes negative 2, and the direction and the sign matters. What that shows is that this data piece of 2 is actually 2 units below the mean. This data piece, which is a 3, is 1 unit below the mean. This data piece is a 4, and it is equal to the mean, so the residual there is 0. Here we'll have a 5, so 5 minus 4 makes 1. It's positive, which means that the data piece is above the mean. And then 6 minus 4 gives us 2 units above the mean. These could be referred to as deviations or residuals, telling us how far away each data piece is from the mean. And we want to keep track of that because what we're about to do next is find what's called the standard deviation. It's a sort of average of the deviations. I'll go over the steps to finding the standard deviation in the next video.